This lesson, we learn how to apply the Ohm's law in series circuit. We begin the lesson with the circuit. So we're going to review the series resistor circuit. We cover some formulas, and at the end, we have one example to show how to use these formulas. So here is that circuit. As you can see, the resistors are connected in series. And these resistors are R1, R2, R3, and then Rn. This is a series resistor system. This system connects to a voltage source called Vt, where T stands for total. So this means the total voltage. Later, we may use different name for voltage source. That is Vs, where S stands for source. So if you look at the Vt here, there are two terminals, the positive and the negative terminals. If you remember, the conventional current is always leaves from the positive terminal and then flow through this circuit, pass through these resistors, and then return back to the negative terminal. This is the current. Let's give a name for this current. We call this IT, the total current. One interesting thing is, if you use the ammeter to measure the current at a point, and then later measure the current at different point, even inside this resistor, and at different points, you can see the reading is same. That means the current is constant. It is uniform. Same speed, same pressure at any point along this circuit. And this is very important concept. It is the first bullet point. Current is same at anywhere in this series resistor circuit. The next bullet point is the total voltage of the system is the sum of all voltage drops. Let's go back to the circuit and look at it again. So we have resistor R1, R2, R3 to Rn. If the voltage drop on R1 is V1, the voltage drop for R2 is V2, and then we have V3 for R3, and then Vn for Rn. The total voltage drop in this system should equal to the voltage source voltage. That means the total voltage this source provided to the system should equal to the voltage absorbed by the system. Let's use one analogy. Let's say there are 10 students in the class, and I'm the teacher. Me, the teacher, donates $1,000 to the class, to the 10 students. Each student receives a portion of the $1,000. They may not receive the same amount, but every student receives a portion of the $1,000. For the entire class, all 10 students together receive $1,000. Me donate $1,000. So the amount of money I donate, $1,000, equals to the total money received by students, the $1,000. So that is same as here. The total voltage of the source, or the total voltage dissipated on the system, equals to the voltage drop on first resistor, plus voltage drop on the second resistor, plus the voltage drop on the third resistor, and all the way to the voltage drop on the last resistor. For the next bullet point, the current in the system IT can be calculated using this formula, and this is Ohm's law. If you remember, there are 3 Ohm's law formulas. One of the formulas is to find the current. That is, the current I equals to voltage divided by resistance. Same as here, the total current in this system is the total voltage of the system divided by the total resistance of the system. Now we are ready to solve the example problem. So here in the circuit in figure 2, first we want to find the total resistance, and then we need to find the current of the system. Now let's solve this question. A, since RT equals to R1 plus R2 plus R3, R1 is 1.0 kilo ohm, R2 is 3.0 kilo ohm, and R3 is 6.0 kilo ohm. If we add them up, that is 10.0 kilo ohm. For B, we know the total current equals to the total voltage Vt divided by the total current of the system RT. Vt is given 12 volt, and RT we just calculated is 10.0 kilo ohm, and this equal to 1.2 milliampere.